This case study begins with speech, using the recorded voice of the composer Joseph Tal, whose work is connected to the early history of electronic music. But it does not stay speech for long. The workflow moves from analysis to generation, from 20th century electroacoustic references to contemporary algorithmic processing, and finally to spatial and proportional finishing. What starts as a voice becomes a layered electronic composition.
נתבקשתי לשוחח עמכם על הנושא המוזיקה במאה ה-20.
The first step is HMM timbre sequencing, and historically this places the project in dialogue with speech technology and statistical listening. Hidden Markov models became foundational in late 20th century speech recognition, especially after the influential HMM tutorial by Lawrence Rabiner, which systematized the model's hidden states, transition probabilities, and decoding procedures for audio sequences. Technologically, this script does something very clear. It takes one selected speech sound, slices it into frames, extracts 4 features per frame: intensity, pitch, spectral centroid, and spectral slope, and then groups those frames into hidden timbre states. In your script, the states are initialized through k-means-like clustering, modeled with Gaussian emissions, connected by learned transition probabilities, and decoded with a Viterbi-style path. So the speech is no longer treated as language. It is treated as a probabilistic map of timbral behavior. Artistically, this is the moment where voice stops functioning as message and starts functioning as material. The result is not a transcription of speech, but a recomposition of its timbral memory. For the video, you can frame this step as a transformation from semantic identity into spectral identity. The speaker is still present, but only as a ghost of tendencies, colors, and transitions. The second step invokes Kotoński FSM event generator, which connects the case study to the history of Polish electroacoustic music. Włodzimierz Kotoński was a pioneer of electronic music in Poland and an early contributor to the Polish Radio Experimental Studio, one of the key centers of post-war tape and electroacoustic practice. Public sources describe his work as central to the development of Polish electronic music, and later commentary on ELA presents it less as a single closed object than as a compositional family shaped by procedures and studio decisions. Technologically, your script does not imitate studio tape work literally. Instead, it translates that historical imagination into a deterministic finite state machine. It generates events through 4 compositional states, with user-controlled state progressions, transition modes, event densities, frequency ranges, and tone versus noise behavior. In other words, the script turns a historical electroacoustic sensibility into a formal engine, structured, repeatable, and visibly parameterized. Artistically, this step introduces form as behavior. The speech-derived HMM layer is about timbral memory. The Kotoński layer is about event logic, pointillism, interruption, clustering, and drift. It gives the piece a sense of articulated motion, almost like a score made from impulses rather than melodies. The third step, Risset's mutations, brings in the legacy of Jean-Claude Risset, one of the defining figures of computer music. IRCAM's records show Risset's major computer-generated works and his close connection to Bell Laboratories, where computer synthesis became a serious compositional medium. Works such as Computer Suite from Little Boy and Mutations stand inside that early history of digitally synthesized sound. Technologically, your script is not a strict reconstruction of one historical score. It is a contemporary generator that schedules overlapping events, shapes them into evolving curves, and pushes them through different nonlinear formulas that emphasize odd harmonics, higher order spectral color, or dense brassy turbulence. The full composition preset even builds a three-part arc, so the script behaves like a form generator as much as a sound generator. Artistically, this step adds instability and illusion. Risset's name is almost synonymous with processes that seem to transform continuously, and your script channels that idea through accelerating, morphing polyrhythmic textures. In the video, this is the point where the case study stops sounding merely constructed and starts sounding uncanny. The fourth step, Stockhausen Study 2 generator, situates the project inside the canon of early electronische Musik. Stockhausen's Study 2 was composed in 1954 for the Cologne Electronic Studio, and later scholarship describes it as the first electronic music piece to be published as a realization score. Earcam also documents the work's 1954 Cologne context and its central place in early electronic music history. Technologically, your script takes that historical reference and turns it into a generative framework. It builds an 81-tone frequency scale using the ratio 5 to the power of 1/25, organizes material into 5-tone mixtures, and offers both a random mode and a serial mode based on Latin square-style permutation logic. So this step contributes something different from the previous ones. Not just texture, but systematized pitch space and formal permutation. Artistically, this is where the case study becomes architectural. The HMM stage remembers the source. The Kotansky stage articulates events. The reset stage destabilizes perception, and the Stockhausen stage imposes order. It gives the composition a historical backbone, a sense that electronic sound can be composed with the same rigor as counterpoint or orchestration. The fifth step is stereo mixer, and historically, this connects the project to the long studio history of stereophonic listening. Britannica notes that the effectiveness of stereophonic reproduction was demonstrated as early as 1933, that two-track stereo became common in the 1950s, and that stereo was valued because it could create a sense of acoustic space and source location. Technologically, your mixer script takes between 1 and 8 sounds, preserves their selection order, automatically handles sample rate mismatches by resampling when needed, and places them in stereo through preset or custom left-right gain structures. In your chain, this is not just utility. It is the point where independent generators become a single field. Artistically, the mixer is where montage becomes space. Instead of hearing separate procedures one after another, we begin hearing a scene: foreground, background, lateral contrast, and depth. This is the step that lets the composition breathe. The sixth step, golden ratio processor, shifts the case study from historical reference to proportional design. The golden ratio, approximately 1.618, goes back to Euclid's description of division in extreme and mean ratio, and later became a persistent idea in theories of proportion, design, and aesthetic balance. Technologically, your script applies phi not as decoration, but as a processing framework. It can reshape pitch, intensity, spectral scaling, spectral filtering, and panning. Most importantly, it defines a golden time structure, where a climax arrives at about 0.618 of the total duration, and in our script the stereo image blooms toward that point before resolving. Artistically, this is the mastering philosophy of the case study. Earlier steps generate material. This one gives that material a proportional destiny. It makes the whole chain feel less like a collection of effects and more like a composed arc with a center of gravity. When the chain is complete, we are no longer hearing a single method. We are hearing a composite argument. A speech recording is abstracted into hidden timbral states, reframed through event logic inspired by electroacoustic modernism, destabilized by Risset-like mutation, disciplined by a Stockhausen reference model, spatialized in stereo, and finally shaped by golden ratio proportion. That is why this works as a case study. It is not only a tool demo, it is a compact history of electronic composition told through one workflow. Speech technology, studio modernism, algorithmic composition, spatial design, and structural proportion, all meeting inside a single chain. This first case study shows how a contemporary Praat-based workflow can function not just as audio processing, but as a compositional environment where analysis, history, and aesthetics become one continuous form.